wrong stuff. Hang on. Here we go. This is what we're actually doing here, and I guess it's going on the same page. Yeah, page 26. Okay, I just have the wrong thing up. Page 26. Okay, so we are going to solve systems of equations by graphing and substitution. And when you start off and you first learn them, and actually what the definition on like the key to these notes says, don't write this down because it's not right. It says 2 or more linear equations, and that's really probably all you've done, but they don't always have to be linear. And so when you push forward farther in your math classes, which includes the college algebra, we could have more than 2, but they don't necessarily have to be linear. So really a system of equations is just 2 or more equations. And to solve them, the number of equations has to equal the number of variables, basically, for you to be able to figure that out. Okay, so there's types of solutions. You could just have one solution, and that would look something like this. And right now we are just talking about lines, but there would be your one solution. I just don't want you to think it's always linear. No solution would be like this. What are those lines called? Parallel. So if I have parallel lines, then there's no solution because they never intersect, right? Because they're parallel. And then another one is if I have this line, and then when I graph my second line, it looks like that. Whoop, well, not like that. I still can't aim well with this. Well, pretend like, oh, there we go. What I was just trying to do, they are this, if it is the same line. Basically, you're graphing the same line on top of each other. That's when it's infinitely many solutions because they share every single point. Okay. So one of the reasons I wanted to go ahead and solve these by graphing, besides the systems part, also to make sure we all know how to graph. Okay. On number 1, we have 2 equations. They are both in y equals mx plus b. So that's nice, right? What does this number represent? Y-intercept, good. So I'm going to go, ooh, these numbers are small. Okay, 3, 4, I think right there. 6, okay, well, kind of. My pen's off, but let me try a little bit better. 1, 2, 3. These are so small, they're just blobs up here to me. All right, and then this part over here is the slope, right? So you got 2 different ways to do it. You know slope is rise over run, right? So it was always strange to me. I don't know how your teacher taught it, but that if you always rise, like I'm going to rise 5, but since it's a negative 5/3, I can run to the left 3. I can do that, or I can go down and to the right. Either way, just make sure that you know that a line with a negative slope looks like that, so in the end you have it correct. You with me? But if I go down 5 and over 3, I probably don't go off of this, right? So I can either go down 5, no, I can't read the numbers, guys, I'm sorry, they're super tiny up here. Is 10 the last one? Okay, so it would go off, so never mind. So we're going to go up 5, and then go to the left 3, 1, 2, 3, and we should end up right there, yes? Now here's the deal, if we're going to solve them by graphing, our graphs have to be pretty darn good. So that's why you want to take your straight edge and like your ID and try and make it go exactly through those 2 points the best you can. I'm going to do the best I can, which is probably not going to be that good, but let's see what happens here. And why it's lime green, I don't know, but okay. So hoping mine was good enough, it would be way better if I could actually use a ruler up here, but I can't because it's a touch screen and things would go bad. So there's a line. We'll pretend like that one's purple too. The color doesn't matter, but I know that green's hard to see. Then we're going to graph the second one. What's my y-intercept? 5? Yes? Okay. My y-intercept is at 5. Okay, again, you're going to pretend like mine's right. And then slope is 1 over 6, so we're going to go up 1 and over 6. About right there. and then you're going to draw in the line to the best of your ability, and you want to see where they intersect, and I think maybe even my bad line is good enough to. The good news is right now these are all whole numbers. There's not going to be anything weird, so it looks to me like this is where we intersect, right? I hate this board. Y'all, this board just irritates the poop out of me. Okay, right there. What's that point? Did y'all have an intersecting point that you could tell on yours? Yes? Should be at -6,4. Do you agree with that? Yes? Okay. And your solutions are always written in ordered pair form. Okay, that's how they work. Everybody good with that? Any questions? Okay. Now, number 2, I got this y equals 5. That's a super easy line to draw, but you have to know if it's horizontal or vertical. What do you think it is? It's horizontal. Did I show y'all the way to remember? I can't remember if I did with the y's and the x's and the h. Okay. So here, let's go up here then, because this is something we can't get mixed up. If I have a horizontal line, okay, or I can have a vertical line, right? And so I got to decide if they are y equals or x equals, and we can't get them mixed up because they're super easy lines to graph, right? So this is a horizontal line, right? I want you to write out a lowercase cursive h like you would learn in like elementary school, just the best of your ability, something like that. It would probably work if it wasn't that either, but. Now, after you do that, turn your paper 180 degrees and tell me what that looks like now. A y, because the horizontal is y equals, okay? Does that make sense? Horizontal is y equals, so this would be like y equals 3 or whatever. If I take x and I rotate it 180 degrees, what is it going to look like? An x, right? It's not exciting. That's okay, because when you split it in half, you get v for vertical, so this is like an x equals 3 line, okay? Whatever you got to do to remember them so you don't get them mixed up, okay? We good with that? Questions? All right, let's go back here and graph this then. Y equals 5. I'm going to go to 1, 2, 3, 4, 5. It's just a horizontal line at 5. Then I'm going to plot this one. My y-intercept is at 7, right? Then my slope up 2 over 1. And then you draw that in to the best of your ability. And there's your point right there. That's at -2, 5. What questions you got? All right. Now, if I turned you loose and on number 3, I wanted you to graph these lines, what would you do first? Because y'all might do different things. Would you put it in y equals mx plus b? Some of you say yes, some of you say no. Is there anything wrong with putting it in y equals mx plus b? Not at all. You said no. What would you do? Okay. So would everybody probably just put it in y equals mx plus b because that's what you know? And that, okay, which is, again, totally fine. There's absolutely nothing wrong with it. But I want you to think about this. When we talk about intercepts, the y-intercept, the intercept on the x-axis, okay, so this is in y equals mx plus b, right? My y-intercept is -5, okay? That happens, I get y equals -5 when x is 0, right? If I substitute a 0 in there, I'm going to get -5. You with me? So when x is 0, I get my y-intercept. When y is 0, I get my x-intercept. So I could just look at the intercepts here instead. So for this one right here, if I zero out the x, if this part is 0, then that gives me -5y equals -45. And then what would y equal? 9. So my y-intercept is at 9. if I take the same equation and this time zero out this term, I get 6x equals negative 45, and this was a bad example because it doesn't come out even. Crap. Never mind. It's going to show y'all, but this is how you can use the intercepts. You could figure it out this way. I should have practiced that way. I did them all in y equals mx plus b also, and then I was like, I really should show them another way. And then this was a bad idea. Okay, never mind. These aren't going to work out nicely. So we'll just forget that one. We're not going to do all these anyway. Let's do, why don't you take this one and put them both into y equals mx plus b. Just do that much, number 5, because we don't need to do all of them. And you can check your equations with me, and if you agree with me, then you can go ahead and graph them. And see what you got. If you don't agree with me, ask me a question. Let's figure out why you don't agree with me. Oops. I think that's where it needs to be. Sorry, I really could use a ruler up here. Negative 6 and up 1 over 4, yeah. It's kind of right there. My graph is terrible because I can't make the line do what I want to do. But, it cut off the answer. What is that? Oh. What did I do? Did I do something wrong? I totally did it wrong. No wonder it's not working out. I'm an idiot. Oh my God. I really did work all these. I went the wrong way. Good. If you don't agree with me, that's a great thing. You should agree with me on the equations. I'm pretty confident in my equations. I just can't graph a line, apparently. No wonder it wasn't. Well, that's probably not the only reason, because I can't. Does that look better? That looks a lot better, right? Whew. Okay. And then let me see if I can do this other one correctly. Negative 6. Eesh. Negative 6. Still not good. Up 1 over 4. Oh, great. I didn't make it long enough. It's like right there, huh? Is it negative 1, 2, 3, negative 4, negative 7? Is that where y'all are? Okay, that's kind of where mine is. I can't even do a, all right. Oh my gosh. Negative 4, negative 7. Sometimes I think y'all could do better off without me. All right, everybody good on that? Perfect, okay, so that's enough with the graphing. Let's flip this over. Now, we've already done a little bit with systems just by the nature of what some of those equations were with those word problems. But here is step by step. You solve one equation for x or y, or maybe they're already solved for you. Substitute, solve, and then substitute again. Right? And again, we've kind of already done this, but we're going to work through some of these so you can see the different things that happen. Now, these are both already solved for y, and some people will say, well, then you set them equal to each other. Yes and no. Technically, it's still substitution. Technically, I'm going to take this and substitute it in right here for y. So that'll give me negative 7x minus 1 equals x minus 9. And then solving that hopefully is a piece of cake. I personally would move the 7 over to the right to give me 8x. I'd move the 9 over to the left to give me 8. And I'd get x equals 1. We agree with that? Then I need to solve for y. It does not matter which one you set it in, substitute back into. I think I'm going to go with this second one. So I get y equals 1 minus 9. So y equals negative 8. And then remember, your systems, the answers are ordered pairs, because it's a point where those two lines intersect. Okay? Everybody okay with that? Yes? All right. Then I think because we've already done some, we can skip number 8. Oh, no. Well, something happens in 8, so I do feel like we need to do it. So let's just do it. We can handle it. You already have one solved, so do you need to, here's something else I see sometimes, is that first one is solved for y. I do not have to set the second one equal to y so it looks just like this. I don't have to solve either one of them, right? I don't have to change it. I can take this and just substitute it in where y goes right there. So 7x plus 3 times negative 5x plus 30 equals 42. And notice when I substituted it in, it was, are y'all talking to each other? Because I'm going to come back there and smack you. Oh. Is she bragging to you? It's rude. You can go ahead and go back. When I substituted something in with more than one term, I put parentheses there so I don't mess something up. So this is going to give me 7x minus 15x plus 90 equals 42. So make sure you actually distribute that to both. So 7x minus 15x is negative 8x. And then I'm going to go ahead and subtract 90 from both sides. So what is that? Negative 48. Are y'all okay with me skipping steps or no? If the answer is no, just let me know. You don't have to announce it to the class. Be like, I'm better off if you don't, and then nobody has to know who it is. So x equals 6. Then I substitute it back in. Which one you want to substitute it into? The first one. So y equals negative 5 times 6 plus 30. So that's negative 30 plus 30. So what does y equal? 0. And a 0 is an okay answer. That's why we did this one. Sometimes when y'all get 0, you think something's wrong. Like, what happened? How do I handle 0? 0's easy. Let it be. Okay? And then always make sure, because you won't necessarily always solve for x and then solve for y. Make sure you put them in the correct order when you put them in your ordered pair. Okay? Everybody good? Any questions? All right. Let's see. I do think we could probably skip number 9. Y'all are okay if we don't do all of these, right? Let's just talk about number 9. Let's just talk about it. If we were going to do this one, and we were going to do substitution, is elimination an option? Yes, but right now we're talking about substitution. If you had to do this by substitution, which equation would you choose and which variable? Because we got to make sure we're making good choices. Because you can choose whatever you want, x or y. Like, let's just think, if I decided I wanted to take the first one and solve for x, I'm going to have to move that 5y over, and then I'm going to have to divide everything by 6. That's going to be yucky, right? But if I do this one and I solve for y, that's just very simply y equals negative 7x plus 22, and it's no big deal, okay? So you can do whichever ones you want. Think about it before you do it. It doesn't always have to be y. It doesn't always have to be the first one. So when we look at number 10, I definitely don't want to solve for something in the second one because nothing's going to divide evenly. And sometimes you can't avoid that. I could solve the top one for y, but I can also, there's nothing wrong with doing it for x. So this will be x equals 7y plus 53. Right? That's what that gave me right there. It's fine to solve for x, or whatever variable you want. Then we're going to substitute it in. So I'm going to get negative 4. I open my parentheses, 7y plus 53 minus 5y equals 19. Okay? Everybody good with that? Then I'm going to distribute. What's negative 4 times 7? Negative 28. Okay? Negative 28y. Then I know negative 4 times 53 is a negative number. What's 2 times 53? 106. What's 2 times 106? 212. There you go. 212 minus 5y equals 19. So then I have negative 28y minus 5y. Give me negative 33y. And then I'm going to add the 212 over here. So watch this. 212 plus 20 would be 232, right? But I'm 1 away from 20, so this will actually be 231. And then I have to divide. What do you know for sure is true about your answer? It's going to be negative. Good. And I'll just tell you it's negative 7. If you got to do big numbers like that, even probably the 4 times 53, you would at least have a 4-function calculator on those tests. So, but there's my y. Now, because I can substitute this back into either one of these, I can actually also use this one. You can use any of what you have before you substitute. So you have 2 variables. So if you want to use this one instead of one of those, you can totally do that, and we can get x is equal to 7 times negative 7 plus 53. What's 7 times a negative 7? Negative 49, good, plus 53 means that x is equal to 4. And then we write our ordered pair, which is 4, negative 7, not negative 7, 4. Be very careful about that. Okay, what questions you got? All right, let's look at number 11. One thing you can do, so let's say that, well, if I just want to, I'm going to solve this for y. Wouldn't you choose the first one and go for y? That would make sense, right? So we just divide everything by 2. This is going to give me y equals 3x plus 10. Everybody good with that? Then we substitute it in. 3x minus 3x plus 10 equals 5. Did I do something wrong? Oh, Jesus. Yes, thank you. Yes, so one thing which I've said over and over again, and don't listen to myself, is when you divide, make sure you actually divide every single term. Thank you for paying attention and calling me out. I'm sorry that it's the simple things that my brain can't do. Now, are these parentheses important? Yes, because I got to distribute that negative, right? So 3x minus 5 equals 5. What's 3x minus 3x? 0. So I get negative 5 equals 5. Is that a true statement? No. You get a weird answer? The answer is no solution. Okay. Now, I know we all know that elimination exists as well, and we are going to talk about that. But right now we're talking substitution, and there's always some students that are just like, no, substitution is the way to go. I'm going to do everything with substitution, and that's fine. You want to do that, but sometimes you make your life harder. Like I could do this with elimination, but remember we're going to pretend like we don't know it yet. So let's do substitution, and really, if you want to choose which one to solve and for what variable, I don't know that there is a good choice up there. Do you? Let's use the second one and let's solve for y, and we're going to practice some fractions. So this would be 4x. I'm going to add the 5 over, and I'm going to move the 3y over like that. See how I moved 3y over, and legally, I didn't just move them, I did math. Okay, so then this gives me, when I divide everything by 3, I'm going to get 4/3 x plus 5/3 equals y. Now, when I substitute it in, and I'm going to get 4x minus 3 times 4/3 x plus 5/3 equals -5. We all agree with that? Oh, no. No. No wonder it's not looking. What did I do wrong? Y'all, I just need to go sit down. Don't laugh at me. It's okay. I got a thick skin. Okay, but this is what happens sometimes. Because I was like, wait, it doesn't look like, that's not what I thought I was supposed to get. I want to make sure you understand what I did wrong, because this is one of the things we can't do. When you substitute it back in, you can't substitute it back into the one you just changed, which is what I did, which is stupid. Okay? Not stupid if you make the mistake, but I feel stupid. That's okay. That is illegal. Do we understand why? Okay. The good news is I'm not going to make you do the whole thing and torture you completely with all the fractions. I just want you to see why sometimes elimination is better. We're actually going to substitute it into this one, which is what we want to do. Y'all, I really do know what I'm doing. Good Lord. I'm embarrassing myself. Okay, 4/3 x plus 5/3 equals -17. Yikesies. All right. So then this is going to give me 5x plus. Now, can I reduce these fractions as I multiply? Like, is the 7 going to cancel out with that 3? No. Are we going to make up math because it's fractions? No. That 7, you can think about it being over 1, and you multiply straight across. So this is going to give me 28/3 times x plus 35/3 equals -17. Okay. Now, can we get rid of those fractions? What do we do to get rid of them? Multiply. Good. Multiply every single term by what? 3. Okay, so literally everything, and let's make sure I can do that. 15x plus 28x plus 35 equals, and I'll be nice and tell you it's -51. I do know that much. Okay. So then when I combine these two, that's what, 43x? Oh, good Lord, I hope so. Yes. And then what am I going to do with this 35? Subtract it over there, so that's going to be what, 86? -86. So what does x equal? -2. Very good. My Lord. And then do I want to substitute it back in right here? I can, but do I have to do it in this one? No. If you don't want to do the fractions, substitute it in here or one of these. It doesn't matter. At this point, it doesn't matter. You can substitute it into anything. And so let's just do what? This version? Is that what y'all want to do? That's fine. That'll work. So we're going to get 4 times a -2 plus 5 equals 3y. So that's -8 plus 5 equals 3y. -3 equals 3y. Y equals what? -1. That was way more painful than it should have been. Sorry about that. -2, -1. Just think about this. I have a degree, well, I don't know what this says about me really, but I have a degree in math and I still make stupid mistakes, okay? So, I mean, it happens. That's why we just got to pay attention to what we're doing. I did sort of halfway catch myself. But weird stuff would have happened when I did that, and I would have realized something else is going on there. But what questions we got? We good? Y'all can handle this?